Hello everyone. Today I want to talk about how to factor any quadratic trinomials in the form of ax squared plus bx plus c, if they're factorable. When I said factorable, I meant factoring over the set of integers. What I want to do here is to give a complete guide on factoring this kind of expressions, which include important details such as how to deal with different signs, ruling out unnecessary combinations to speed up, and other tips and strategies. And I will do another video for a lot of examples later on. Let's get started. Looking at a problem where a is not equal to 1, one of the most popular methods for factoring a trinomial like this is called the AC method. In this method, what we do is that we will first have to multiply the numbers a and c. That means multiplying 3 and negative 8, which gives us negative 24. And then we gotta draw this giant X and putting that negative 24 at the top and put the B at the bottom. So you see here. What we do next is that we'll need to figure out two numbers that will multiply to negative 24. Here are all the combinations, ignoring the signs here. We then need to check each combination to see which can give the B by addition or subtraction. So it's this one, 4 and 6, because 6 minus 4 gives 2. After that, there are different things that I see people do here. I will just quickly show them. One of them is to split the middle term and do factor by grouping. Another is to do what some people call tricks in the giant X and figure out the factors. Well, they're really the same thing, just look differently. This video is not about this method because it's way too many steps. And it's only nice for relatively simpler problems. How about trying it on 24x squared plus 2x minus 15? The method that I want to talk about here is the trial and error method, but we'll do it in a way that actually shows the process of reversing the foiling. One reason for why so many people try to avoid using trial and error is because we don't like failing. When it comes to doing trial and error, it's inevitable that we'll run into getting the wrong combination and fail. We don't like that feeling. No one likes failure. But I will tell you, besides the fact that failure is part of life, when you get used to doing it, you'll usually get the right combination within 2 or 3 tries. Here, let's try the same problem using trial and error. We first put down 1x and 3x because they multiply to 3x squared. Because 3 is prime, we only have this combination. Now, for the negative 8, I am just going to pick 4 and 2. We'll worry about the sign later. Let's place the 4 and 2 like this. We multiply them this way, following the lines. So 1x times 2 gives us 2x. And 3x times 4 gives us 12x. Adding or subtracting these, we get either 14x or 10x, ignoring the signs for now. We immediately know that this does not work because we are supposed to be getting the 2x. So we failed. But that's no big deal. Let's quickly try switching the 4 and the 2. After multiplying, we get 6x and 4x. Adding or subtracting these, we get either 10x or 2x. And we get what we want, the 2x. We now only need to worry about the signs. In order for us to get negative 8, one of these numbers, 2 and 4, should be negative. Since we want positive 2x, we want a negative sign only in front of the 4x. At the same time, we put the minus sign in front of the 4. We are now done. How do we write down the final answer? The answer is basically there. We just read across and we can write down the answers easily. See, it's not that bad, right? I'm gonna do another example. Before we continue, please take a second to subscribe to my channel for my math videos. Your support is extremely important to me. Let's look at another problem. Instead of running through the whole process again, I'm going to quickly show all the tries. Among all these tries, we can see that this one is the only one that can give us a 19 by adding or subtracting. All we need now is to adjust the sign. Then we have our answer. We need to have a minus sign in front of each of both 15x and 4x so that we can sum them to get negative 19x. Also, it's important to notice that negative 5 and negative 2 will multiply to positive 10. So now all the signs are correct. So we can read across and write the factors. Coming back to the problem, you may say that's a lot of tries, but how long does it take to try one? No more than 10 seconds. Now let me share a trick here that will allow us to rule out some of them. Let's look at our first try. Even without the multiplication result, I can easily tell that this will not work. Why? Let's pretend that it's the correct factorization. If we write out the factors, ignoring the signs for now, then we have x plus or minus 1, 6x plus or minus 10. The reason for why I know that it doesn't work is that we can factor out a 2 from the 6x and 10. See the problem here? If we can factor a 2 from the factor form, then we should be able to factor a 2 from the original expression. But you can see that we can't. So we can rule out this first one. Using the same idea, we can rule out all these ones, the ones with a GCF. How many do we have left to try? Only 4. It should take less than a minute to try the rest. Just don't be afraid of trying. If it's factorable, you know that you will eventually get the answer. Let's look at an example with negative 3 as the greatest common factor. You may ask, should we factor out negative 3 from each term first? Yes, we should. But we can still use the method of trial and error without having to deal with the GCF first, if the GCF is constant. Here's the answer. See that we eventually still have to factor out negative 3 from negative 3x minus 6? Well, what if the GCF contains variables? Then the situation becomes more complicated, and we should factor out the GCF first. Okay, I also want to talk about how to use this method to factor trinomial expressions in quadratic form. For example, this is not a quadratic expression, but it's in quadratic form, which will allow us to factor like how we did it to quadratic trinomials. And here is the correct answer for it. So, how do you feel? Are you feeling better about using trial and error? Before we end this video, you should help him complete the factoring. I know that this video is only about the idea. If you're more interested in example videos, stay tuned for them. If you like this video, please give me a like, subscribe my channel, and share my videos to others. I'm Wilson. Thank you for watching. See you next time.